standard test method for specific gravity and absorption of fine aggregate. This method covers the determination of bulk and apparent specific gravity and absorption of fine aggregate. Bulk specific gravity and absorption are material characteristics commonly used to determine quantity and moisture content of fine aggregate in concrete mix design. Equipment needed to run the test includes a scale or balance having a capacity of 1 kilogram or more, sensitive to 1/10 of a gram, and accurate to within 0.1% of the test load at any point within the range of this test. A volumetric flask of 500 cubic centimeters capacity, or a fruit jar fitted with a pycnometer top. A metal mold in the form of a truncated cone measuring 40 millimeters plus or minus 3 millimeters inside diameter at the top, 90 millimeters plus or minus 3 millimeters inside diameter at the bottom, and 75 millimeters plus or minus 3 millimeters in height. The metal must have a minimum thickness of 0.8 of a millimeter. A metal tamper weighing 340 grams plus or minus 15 grams and having a flat circular tamping face 25 millimeters plus or minus 3 millimeters in diameter. To prepare a sample, obtain a quantity of fine aggregate in accordance with ASTM D75 sampling aggregates. Separate approximately 1 kilogram of the fine aggregate from the sample using ASTM method C702, reducing field samples of aggregate to testing size. Dry the test sample in a suitable pan or vessel to constant weight at a temperature of 230 degrees Fahrenheit plus or minus 9 degrees. Allow the test specimen to cool in air at room temperature until it is comfortable to handle. Add water until the specimen is covered and allow it to stand for 24 hours plus or minus 4 hours. After the 24-hour soaking period, pour off the excess water carefully to avoid loss of fines and bring the test specimen to a saturated surface dry condition. Saturated surface dry condition is achieved by uniform drying of the test specimen. To do this, spread the sample on a flat, non-absorbent surface and expose it to a gently moving current of warm air. Stir the sample frequently. If desired, mechanical tumbling or stirring aids may be used to help the specimen reach the saturated surface dry condition. Continue to stir the specimen until it approaches a free-flowing condition. Perform the cone test to determine when the fine aggregate has attained saturated surface dry condition. To run the cone test, use the mold previously shown and hold it firmly on a smooth, non-absorbent surface with the large diameter down. Place a portion of the partially dried fine aggregate loosely in the mold, filling it to overflowing. Heap additional material above the top of the mold by holding it with the cupped fingers of the hand holding the mold. Lightly tamp the fine aggregate into the mold with 25 drops of the tamper. Each drop should start about 5 millimeters above the top surface of the fine aggregate. Let the tamper fall freely on each drop. Adjust the starting height to the new surface elevation after each drop and distribute the drops over the surface. Remove loose sand from the base and lift the mold vertically. If surface moisture is still present, the fine aggregate will stay in its molded shape. If the fine aggregate slumps slightly, this shows that it has reached a surface dry condition. The first cone test should indicate some surface water on the specimen. Continue drying with constant stirring and test at frequent intervals until the test shows that the specimen has reached a surface dry condition. If the first cone test indicates there is no moisture on the surface, thoroughly mix a few milliliters of water with the fine aggregate and allow to stand in a covered container for 30 minutes. Then resume the process of drying and testing at frequent intervals to surface dry condition. There are several ways to determine the specific gravity of fine aggregate. Here we will use the volumetric flask method. Partially fill the flask with water. Pour 500 grams of saturated surface dry aggregate into the flask and fill it with additional water to approximately 90% of capacity. Roll, invert, and agitate the flask to remove air bubbles. This will take about 15 to 20 minutes. The temperature of the water and test sample should be 73.4 degrees Fahrenheit plus or minus 3 degrees. Adjust it, if necessary, by immersion in circulating water. Bring the water level in the flask to its calibrated capacity and determine the total weight of the flask, test specimen, and water. Record this and all other weights to the nearest 1/10 of a gram. Our total weight is 992.8 grams. Remove the fine aggregate from the flask by pouring it into a suitable size container, making sure to remove all of the test sample by rinsing with additional water if necessary. Carefully pour off the excess water to avoid loss of fines and dry the sample to constant weight at a temperature of 230 degrees Fahrenheit plus or minus 9 degrees. Cool it in air at room temperature for 1/2 hour to 1½ hours and weigh it to the nearest 1/10 of a gram. The weight of our test sample, oven dry, is 492.6 grams. To calculate the bulk-specific gravity of the fine aggregate, we also need to know the weight of the flask filled to its calibration capacity with water at 73.4 degrees Fahrenheit plus or minus 3 degrees. The weight of our flask filled with water is 677.3 grams. To determine the bulk-specific gravity of our test sample, divide the weight of the oven-dry specimen in air, 492.6 grams, by the weight of the flask filled with water, 677.3 grams, plus the weight of the test sample saturated surface dry, 500 grams, minus the weight of the flask with test sample and water to the calibration mark, 992.8 grams. The bulk-specific gravity of our test sample is 2.67. Bulk-specific gravity based on the oven-dry weight of the aggregate is used when the aggregate is dry or assumed to be dry. Bulk-specific gravity saturated surface dry is used if the aggregate is wet, that is, if water fills the pores of the aggregate. The bulk-specific gravity saturated surface dry can be calculated by dividing the weight of the test sample, saturated surface dry, 500 grams, by the weight of the flask filled with water, 677.3 grams, plus the weight of the test sample, saturated surface dry, 500 grams, minus the weight of flask with test sample and water to calibration mark, 992.8 grams. The bulk-specific gravity saturated surface dry of our test sample is 2.71. Absorption, also used in the design of concrete mixtures, can be found by dividing the difference in weight of the saturated surface dry test sample in air, 500 grams, and the weight of the oven-dry test sample in air, 492.6 grams, by the weight of the oven-dry test sample in air, 492.6 grams. Multiply the result by 100 for percent. The percent absorption of our test sample is 1.50. When reporting the results of these tests, remember to report specific gravity to the nearest 100th and indicate the type of specific gravity, whether bulk or bulk saturated surface dry. Report absorption to the nearest 1/10 of a percent. If the fine aggregate was tested in a naturally moist condition other than the oven-dried and 24-hour soaked condition, report the source of the sample and the procedures used to prevent drying before testing.